So first part we discussed about what is kinetic energy, what is potential energy, what is the work done and what is the scalar product. Now we are going to discuss about law of conservation of energy. What is the law of conservation of energy? Energy can neither be created nor be destroyed, but it can be transferred from one form to the another form. So that is the law of conservation of energy, and I think you know in the case of freely falling body how it is applicable in the case of law of conservation of energy in the case of freely falling body. Suppose this is at point A, then it reached to the at point B, then it reached to the ground. You should consider the point is the C. So at A, entire energy is in terms of potential energy. Here kinetic energy is 0, potential energy is mgh, because from here to here the height is h and the distance is x, means this is the h minus x. But at point B, it is having both kinetic energy and potential energy. Potential energy is how much? Anyway, height is the h minus x. But kinetic energy we are taking half into m into vb square. So velocity at B is how much? Anyway, first velocity is 0, means here VA equals to 0, and here you should consider VB. VB square equals to 2gx. 2gx. Here 2 cancel. Finally you are getting total energy here also mgh only. Like that at C, it is on ground, means clearly potential energy is 0, but kinetic energy after simplification we are getting the mgh only. So once again total energy is how much? mgh. So from this what you are understanding, at A the entire energy is in terms of kinetic energy, potential energy. At C the entire energy is in terms of the kinetic energy. So this is the law of conservation of energy in the case of freely falling body. Then we are going to discuss about power. What is the power? Rate of doing work. Rate of doing work is called the power. So simply we can write it, power equals to work by time. But instead of work we can write it F bar dot S bar by time. It should be right displacement by time is the velocity. It should be right FV cos theta also. See, don't stick only for work by time. You should express in terms of dot product also. You should express in terms of that you should consider the cos theta also. Then from this, look here, there are different cases. If we are firing n number of bullets, then this work is stored as a kinetic energy. So P equals to how many number of bullets? N number of bullets. Each bullet mass is mv square by t. Suppose we do one problem here. If n equals to 100, each bullet mass is 10 grams, velocity equals to 10 meters per second, then the time equals to 10 seconds. Then how to find out the power? Simply you can write it. This is the 100 into 1 by 2 into mass of each one is 10, but we must convert into SI system 10 to the power of minus 3. Velocity square means 10 square. But time is also how much? 10. This 10 cancel. This is how much? 50. Finally power equals to how much? 5. 5 watts. That is the power of the gun. So you are taking gun, you are firing the bullets, means that work is stored as a kinetic energy, but we want to find out the power, means work by time we are taking. Like that, this is the one bucket of water you are lifting here. So how much power is there? Instead of work done, potential energy by time we are taking. Potential energy by time. Like that you are taking some one well is there. You are bringing the water and you are ejecting with how much velocity v, and you are bringing from how much height through how much height h. In this case power equals to mgh plus half mv square by time. So you remember that this is about the power, and power unit is the watt and it is the scalar quantity. Horsepower means 746 watts. 1 horsepower equals to 746 watts. So this is about the power. Now we are going to discuss about collision. What is the collision? A strong interaction between the particles is called the collision. During the collision, what happens? The momentum is redistributing between the particles. So, what are the two types of collisions? One is the elastic collision, another one is the inelastic collision. What is elastic collision? In this, both momentum and kinetic energy are conserved. Inelastic collision means only momentum is conserved. In one-dimensional elastic collision, you are having one of the long answer. From this only you are getting most of the expressions. See, elastic collision in one-dimensional motion. Elastic collision in one-dimensional motion. See, look here. This is first body of mass is m1. This is the second body of mass is m2. u1. This is the u2. This is what before collision. This is the during the collision. And this is the after collision. No changes in masses, but the velocities are v1 and v2. Anyway, it follows law of conservation of momentum, means m1 v1 plus m2 v2 equals to m1, sorry, this is u1 u2 v1 plus m2 v2. Here you are getting the expressions for relative velocity of approach equals to relative velocity of separation. Relative velocity of approach means u1 minus u2, means before collision both are coming like this, is equals to relative velocity of separation means v2 minus v1. So this is the relative velocity of approach and this is the relative velocity of separation. From this you are getting the expression for v1. v1 is what? m1 minus m2 into u1 plus 2m2 u2 by m1 plus m2. See, look here. When you know the masses and before collision velocities, you can find out the velocities after collision. This is the after collision first body velocity. Like that, after collision, what is the second body velocity? v2 equals to m2 minus m1 into u2 plus 2m1 u1 by m1 plus m2. And here some special cases also it's there. Suppose if m1 equals to m2 equals to m, then what about the first body velocity? Before collision, first body velocity is u1, second body velocity is the v2, u2. Then what about after collision? See, after simplification, v1 equals to, this term becomes to 0. 2m by 2m is cancelled, v1 equals to u2 and v2 equals to u1. From this, what you are understanding, if masses are same, velocities are interchanging. Velocities are interchanging. See, what is the meaning for that? Suppose before collision, first body velocity is the 5 meters per second. Second body velocity is the 10 meters per second. Both are having the same mass. After collision, 10 meters per second velocity becomes to first body velocity. 5 meters per second is going to second body. So here simply you can write it, v1 equals to 10 meters per second and v2 equals to 5 meters per second. Within fraction of seconds you can give this answer. Like that, here we are taking one more case. This is one small body m1. This is moving with how much velocity? u1, and it is making collision with m2. Here m2 is very greater than m1. Then after collision, what is the velocity of first body? Minus u1, it comes reverse. Then as usual this velocity is 0. Like that, one small body is there, one big body is there. Here m2 is very less than m1. This is moving with how much velocity? u1, and here velocity equals to 0. So in this case, after collision, v1 is what? Same. v1 is like u1 only, but v2 equals to 2 times of that first body, 2u1, like that. So like that, there are different cases to find out this one. So you must by heart these formulas or remember, that is your wish, how you should remember, but you must follow these formulas to solve the problems. And one more application we are doing here, that is, see, elastic collision only, but first body is moving with how much velocity? m1, and it is moving with u1 velocity, making collision with second body of mass is m2, but here u2 equals to 0, means second body is at rest. Second body is at rest. Then how to find out the V1? What is expression for V1? M1 minus M2. M1 minus M2 U1 by M1 plus M2. There is no second term here because this U2 equals to 0. Then how to find out the kinetic energy after collision? Kinetic energy, final kinetic energy is how much? Half M1 V1 square. So here what we are getting, half into M1 into V1 square means U1 square into M1 minus M2 by M1 plus M2. M1 plus M2 whole square. Like that, fraction of final kinetic energy of first body to the before collision means what we are taking when it comes, you know that half M1 U1 square is the before collision kinetic energy. This fraction is how much? Simply you should get it, M1 minus M2 by M1 plus M2 whole square. Like that, what about the second body? You know that V2 equals to M2 minus M1 into U2 by M1 plus M2. This is the second body. Second body velocity after collision. So after simplifications and all this, here also after collision, what is the kinetic energy means what is the formula? Half M2 V2 square. Half M2 V2 square. Here M2 minus M1 into U2 here we are getting. So half M2 into V2 square means you can take it M2 minus M1 by M1 plus M2 whole square. But the thing is here U2 is 0. Here what we are taking, V2 equals to, what is the formula? V2 equals to M2 minus M1 U2. Second term is the left. First term becomes to 0. Second one is the 2 M1 U1 by M1 plus M2. So kinetic energy of second body is how much? Half M2 V2 square. Then half M2 V2 square means here 4 M1, otherwise 2 M1 U1 by M1 plus M2 whole square. So this is the kinetic energy after collision. Here fraction of kinetic energy of second body before collision first body means what we are taking here, half M1 U1 square. What we are taking kinetic energy. Remaining is what? Remaining is what? 2 square is the 4. Okay. So half is went to this side, only M2 M1, otherwise we can write it M1 M2 by M1 plus M2 whole square. So this is also one of the important model. From this we can find out, suppose we do one problem also. If M1 is the 4 kgs, M2 is the 2 kgs, M2 is the 2 kgs, then how to find out the, here clearly they said U2 equals to 0. Find the fraction of kinetic energy of first body, second body means here 4 minus 2 how much? 2 by M1 plus M2 is the 6. Answer is how much? 1 by 9. Here fraction is how much in the case of second body? 4 into 2 by 6 whole square means 36. So 8 by 9. Like that we can be able to do the problems. Then we are going to discuss about coefficient of restitution. What is the coefficient of restitution? It is the ratio of relative velocity of separation after collision to the relative velocity of approach before collision. See, coefficient of restitution, it is represented by E. Then what is the formula for E? E equals to relative velocity of separation after collision to the relative velocity of approach before collision. You remember that E equals to 1 for perfect elastic collision. Then E equals to 0 for perfect inelastic collision. Then not only this one, suppose you are taking one ball is there, it is making collision with second body. Okay, here V equals to how much? Suppose this is the H. V equals to under root 2g H1. When it goes to H2, then that velocity is how much you are taking? U equals to V2 equals to V1. This is the V2 under root 2g H2. In both the cases, Second body is at rest condition. Here you are getting E equals to under root H2 by H1. Suppose you are taking n number of rebounds. N number of rebounds. Suppose one ball is striking with this and it is making like second one, third one, fourth one, like fifth one, like that, n number of rebounds. At that time, height is how much for nth rebound? E to the power of 2n into h. Suppose E equals to 1, h equals to 100. 2 rebounds means instead of 2n, we are taking 2, instead of h 100, and instead of E we are taking 1. Then easily you can able to find out the height. Like that, for nth rebound, velocity means e to the power of n into initial velocity. You must remember this one. Like that, here few more cases are there. The distance travel for n number of rebounds. So d equals to h into 1 plus e square by 1 minus e square. Okay, like that, time is how much for n number of rebounds? 2h by g into 1 plus e by 1 minus e. Suppose you know the distance and the time, how to find out the average speed? So h into 1 plus e square by 1 minus e square divided by under root 2h by g into 1 plus e by 1 minus e. And one more thing, after n number of rebounds it comes to rest. So how much displacement it covers means nothing but height of this one. Displacement means starting position to ending position. In this case, simply you can say that distance is this one, but displacement is how much? Displacement is initial height of this one from where it has started. Like that, inelastic collision. In the case of inelastic collision, after collision, see, this is the first body and this is the second body. This is moving with how much velocity? u1, and this is moving with how much velocity? u2. After collision, for perfect elastic collision, both are stick together and move with common velocity. This is called the inelastic collision. Then how to write the expressions here? See, m1 u1 plus m2 u2 equals to m1 plus m2 into v. From this v equals to what we are writing? m1 u1 plus m2 u2 by m1 plus m2. Like that, we should find out the common velocity. Not only this one, if both the bodies are moving opposite direction, you can take it. Those are in between minus, you can take it in elastic collision and all these conditions. So this is about the elastic collision and power, and first part I have given energy, work done, kinetic energy and scalar product. So this is somewhat big chapter. You must learn that formulas, then only you can able to do the problems. Okay, and many people are having so much of confusion while going through the crash course. See, when you are subscribing only, you are getting the playlist on the top of my channel. When you are pressing the physics crash course 2022 is there, you should follow day wise. I have given already 21 days are over, so this is the 22 and 23 I am posting. Don't leave this chapter. This chapter is very important. You can expect 2 questions for MSET. You can expect 2 questions for the NEET also. Thank you everyone. Please subscribe my channel, and in this moment you can share my channel also.